Before a weld can be inspected, and before a further bead can be laid upon an existing bead, the layer of slag will have to be removed. This is achieved using the chipping hammer. If you have made a very good weld, the slag will come away easily from the bead. It must be noted that slag should be chipped away only after the weld has had sufficient time to cool and the slag has hardened. In many cases, however, the slag will not separate easily, and considerable chipping may be necessary. It is for this reason that you should wear your welding mask with the visor lifted up when chipping. Further cleaning and removal of loosened particles is achieved using the wire brush. Having cleaned an existing weld, we are now able to examine or read the weld. The term reading a weld is used to describe the act of closely inspecting a weld and determining what, if any, corrective action we must take. A good weld has the following characteristics: bullet-shaped ripples spaced fairly evenly apart, a consistent face width of between 2 and 3 times the diameter of the electrode wire, and sufficient penetration into the base metal. If we look at the shape of the ripples on this weld, we see that they are bullet-shaped or C-shaped, and that they are fairly evenly spaced. Further, we can see that the bead width is consistent and approximately 3 wire diameters across. If we were to view the weld bead in cross-section, it should look like this. A good weld is the result of combining 3 critical elements, namely the correct welding current, the correct arc length, and the correct speed of travel. If any one or all of these critical elements is not correct, then the result will be a poor weld. Let's look at some examples of poor welds. In this first example, we see the result of welding using a welding current that has been set too low. The bead has not penetrated the base metal owing to insufficient heat being generated in the metal. In the next example, we see a bead that has been laid using an excessively high current. Excessive current results in a bead that is too wide, too low, and full of spatter. Spatter is the term given to the little metal deposits formed by the cooling of sparks that surround the weld area. This example is the result of holding an incorrect arc length. Here the arc length was too short, resulting in a narrow bead with little penetration. By contrast, an arc that is too long will produce a bead like this. Note the undercut at the edges of the bead, the untidiness of the ripples, and the excess of spatter. The next example illustrates the result of traveling too slowly with the electrode. The bead is wide, the ripples are flatter than normal, and the filler material is built up excessively. This last example illustrates the result of the travel speed being made too fast. The obvious visual signs of this problem are the sharply pointed ripples and the narrowness of the bead. This concludes Video 1 of Program 3. Practice reading your own welds and make the necessary changes to your welding until you are able to consistently produce a good stringer bead.